To my channel. Today we'll be examining how to quickly compute some big powers. For example, if we have 99 to the power 4, 101 to the power 5, and we'll be looking at an easy way to compute those quickly in maths competitions. So for that, we'll need to examine something called the binomial theorem, which I have written down here. This states that a plus b to the power n, there's a general formula for this, and we'll be learning how to expand the powers with this. So the best way to learn is by example. So we'll just do a quick example of expanding a plus b to the power 5. Alright. So how you do this? First of all, you list down the variable parts of the terms. And how to do that? This is a power which we are raising to. Let's call it n. So n is equal to 5. So the first term will be a to the power n, which will be a to the power 5. This will be the variable part of the first term. And every next term that we go, we'll decrease the power of a by 1 and we'll increase the power of b by 1. So you can think of this as being a to the 5 into b to the power 0, as anything to the power 0 is just 1. So next term, we will decrease a by 1 and increase b by 1. So next term, our variable part will be a to the 4, b to the 1. And like this, we can write down the rest of the expression. So this is the rest of the expression. We can just remove this b to the 0 here. So now we have gotten the variable parts of the terms. Now what we need to grab is the coefficients. And the coefficients are found using this formula as I've shown here. So basically, let's say this is the 0th term, this is the first term, this is the second term, etc. So the coefficient will be n choose the number of the term. And if you remember this formula, this is n factorial over k factorial n minus k factorial. So let's compute what the first term will be. This will be 5 factorial over 0 factorial 5 factorial. So 0 factorial is 1, this cancel out, so the coefficient will be 1. And one thing that you can do to speed up this process is that if the first term, its coefficient is, let's say, x, then the last term's coefficient will also be x. If the second term's coefficient is x, then the second last term's coefficient will also be x. So they are sort of symmetric in a way. So we can say that the first and the last term, their coefficients are dealt with, they're 1, so we don't need to mention them. So now let's compute the coefficient for the second term. So this will be 5 choose 1, which will be 5 factorial over 1 factorial 4 factorial. And what you will notice, this is 5 into 4 into 3 into 2 upon 4 into 3 into 2. So this will easily get cancelled and we'll be left with 5. So this will be 5, and as I said, second term coefficient is x, second last term coefficient will also be x. So we can write a 5 over here. Now we just need to find out the coefficient of this term, and by that this term's coefficient will also be found out. So that will be 5 factorial over this is the 0 1 2 term, so it will be 2 factorial 3 factorial. So we can write this as 5 4 3 2 upon 2 into 3 into 2. Now we can easily just cancel this, and this is equal to 10. So again 10 here, third term 10, so third last term will also be 10. So this is our expansion which we have gotten of a plus b to the power 5, and like this we can take off any natural number like a plus b to the power 10 even we can go up to, but that is a bit time taking. So now we'll be looking at these two questions. First of all, the question is to find 101 to the power of 5. So this question we can do it in an easy way. we'll notice that 101 is just 100 plus 1. And we have a formula here for a plus b to the power 5. So we can simply just write this as 100 plus 1 to the power 5. And since we have this formula over here, we can use this to expand the series. So first term will be a to the 5. In this case a is 100, so it will simply be 100 to the power 5. Next term is 5 a to the 4b. So 5 100 to the 4, we can just write that. And again b is just 1, so we don't need to show anything for that. I will step through the next terms also. You can take this at your own pace. And the last term that we get to, we'll notice it's b to the 5 and 1 to the 5 is just 1. So here we'll write 1. So this is our expansion which we have. Now we can easily find the product. So this will be 10 to the power of 10. So we'll have 1 with 10 zeros in front of it. And our next is going to be 10 to the power 8. So 10 to the power 9, there's a 0 here. 105. Again there's a 0 here. And this is 10 into 10 to 100 to the power 3. So we can basically write this as 10 to the power 7. So this will only come here as 1. This will be 10 to the power of 5. So we'll leave a 0 then a 1. And since this is 10 to the power 5 and this is just 10 to the power 2. So we'll leave 2 zeros and we'll have 5, 0, 1. So this is the expansion we found out. If you didn't understand the last step, you can just try to compute this by whatever method you want to. You will just arrive at the same answer, which is this. Now for the next question, we have to find 49 to the power 4. And actually we haven't gotten an expansion for the a plus b to the power 4 yet. So let's just see if we can find that out. A plus b to the power 4. So again we'll be applying the same formula. First we'll list down the the variables, which are going to be a to the 4 plus a cube b plus a squared b squared, ab cubed plus b to the 4th. And if you didn't understand this, you can walk through the last thing. As we can see, a to the 4 here, a keeps decreasing and b keeps increasing. Now we can work out the coefficients again. First coefficient actually, so we'll do, since our n is 4 here, we'll have 4 factorial over 0 factorial 4 factorial. This cancels out to 1. So first and last term, coefficients will be 1. Second term will be 4 factorial over 1 factorial 3 factorial. And this is 4 into 3 into 2 upon 3 into 2. So we can cancel that. So this term will be 4. And this term will also be 4. And now we just need to find the coefficient of the middle term. So this will be 4 factorial over 2 factorial, 4 minus 2 factorial, which is this 2 factorial. So this is 4 factorial actually, it is equal to 24 and 2 factorial is just equal to 2. So this term will come out to be 6. So as I said, now we are going to find out 49 to the power 4. We have an expansion of a plus b to the power 4. And you can do this in 2 ways. First of all, you can notice that this is 40 plus 9 to the power 4. But that will require a little more work because 40 and 9 aren't as easy to deal with. You can notice that this is much closer to 50 than it is to 40. So we can write it as 50 minus 1 to the power 4. This really depends on the number. If I had something like 42 to the power 4, I would just write it as 40 plus 2 and do it in that way. So this is 50 minus 1 to the power 4. And here you'll notice that our b is in negative. So we will actually have some negative coefficients in this sum. So let's just find this out as we did before. This will be 50 to the power 4 plus 4 into 50 cubed into, and now you'll notice here b is actually minus 1. So this term will come out being negative. So we can remove this plus sign and replace it with negative. And this is plus Here we can see that negative 1 is going to be squared, so it will just end up in being 1. So we can safely write a plus here. And 6 into 50 squared. 50 squared. Next term again, we'll notice that this is b cubed. Minus 1 cubed is just minus 1. So this term will also be negative. Minus 4 into 50. And finally, minus 1 to the power 4 is just 1. So I've just gone ahead and written out these powers for you. So now we can easily just do a bit of arithmetic to get this answer. So this, if we subtract these two terms, it will come out to 575,000. We subtract these two terms and we can also add on the 1. It will be plus 14801. So our answer will come out to be 5764801. So this is 49 to the power 4, which we found using this method. So from now on, if you get any big power, like if you get 97 to the power 5 or 52 to the power 7, then this is just what you need to do. Round it off to the nearest multiple of 10. Like for example, for 97 you can use 100 minus 3. For 52 you can use 50 plus 2. And then find the binomial expansion and then compute it using the power. So that is the best method to deal with these questions. Done.